to a generator. Now, what is the difference now? You will see most of the same components. Let us give it exactly the same components. Again, my magnet, but the difference is now there is no cell in the external circuit. I've just got a voltmeter here to show me the induced potential difference. So there's no external circuit with cells provided. So in this case, I'm applying a force, so I'm turning this section so that it turns. And now current is induced. So what we have is that mechanical energy is now converted to electrical energy. So I can again show the magnetic field from north to south. I can show the induced current, and I can show the direction of movement. Now the direction of movement, I'm going to turn it anti-clockwise. So there you can see that there is now a current induced, and my together with an induced potential difference, and that is what my voltmeter is showing here. I'll be coming back again later to look at the components, to look at the working, but I shortly want to show you the difference, how to see the difference in energy. In this case, you can see I'm applying a mechanical force here, so the force is mechanical energy converted into electrical energy. All right, so let's go back to the PowerPoint, where we will now specifically look at the motor. So I'm looking at the motor, the electric motor. So in the electric motor, the energy conversion is electrical energy to mechanical energy. So you should know this, and then you can tick that box. We know what is the energy conversion in an electrical motor. All right. The principle on which the electrical motor is functioning is called the motor effect. That is the word that we give to it, and we will look at that in more detail. Right, so we even now can tick the principle. If in the exam you are being asked what is the principle on which the electrical motor is functioning, then you just answer the motor effect. All right, so what is happening there in the electrical motor? Current is supplied. In the external circuit, I have a cell, and it is supplying current. All right. So that current is then, what is the product of that current that's flowing? That current is in a magnetic field, and a force is the product. And that mechanical energy, where the electrical energy is converted to mechanical energy, that is seen in the movement. It is turning. All right. So this in short shows me the principle and the energy conversion in an electrical motor. All right. If we go then more into detail on the motor effect, the principle on which it is working. Current is supplied, and the force is the product. All right. What can we do now? We have a rule, Fleming's left-hand motor rule. With this rule, we can predict the direction of movement. Now, in this rule, you will see that there's three very important parts that forms part of the rule. And with the electric motor, this rule, we use our left hand to be able to see the influence of these three factors that influences the direction of motion that will be experienced in the electrical motor. The thumb is associated with the direction of motion, the force direction. Right? My finger is the index finger. That is my magnetic field, and the middle finger, that is associated with the current in the conductor. So if you can focus on me on the camera, then I can just want to show you that we keep our left hand in this way, so that each one of these three sections form a 90-degree with one another. All right, so the thumb will then be the force that is experienced. The index finger would be my magnetic field direction, and this will be my current direction. Now, if I know the current, in which direction it is provided through the cells, and I know the magnetic field direction, which is always from north to south, then my thumb will show me in what direction will the electric motor experience a force, and in which direction it will then move. So you can use this in exam, and don't feel bad or anything when in the exam time you sit there with your left hand and you work out. That is fully acceptable, that you take your left hand quickly and you do what you need to do and you see the direction that the movement is going to take place. Sometimes in questions, however, we will say it's turning clockwise and we will give you the current direction. Then I can deduct the third one, which in this case will then be the magnetic field direction, north and south of the magnet. Sometimes we don't supply you with the current direction, but we say in which direction it's turning, and we are giving you the magnetic field direction. So then I can deduct the third one, which is the current direction. So it depends on which two you will receive, and that will help you to determine the third one that you actually need. So if I can go back to my PowerPoint. Right, let's go back to our slide on Fleming's left-hand motor rule. One of the common mistakes we see in exam time is that learners forget that the left hand must be used with the electric motor. Just by habit or not focusing or concentration, question of concentration, you sometimes uses your right hand. Don't get that wrong, because then your directions will be wrong. If I take the two hands, you can see if these two fingers are pointing in the same direction, my thumb is in the same direction, my middle finger is in the opposite direction. So you won't get the right answer if you use the wrong hand. So be very sure that you understand how to use this rule. All right, so what have we looked at so far? We've looked at the energy conversion, and we've looked at the principle, and we started to look at explaining the working. All right, let's go on. Now, before we do the rest of electrical motors, just a convention, how we want to show if the direction of current flow. If the current is flowing into a page, then you must now see three-dimensionally a current that's going into my page, away from my face, into the page. Then we use a circle with a little cross in the circle. And if the current is coming out of the page directly to your eyes, and that is the opposite direction, then we just have a little dot. I always, when I was still teaching, I used to tell the learners, think of a dart. When I'm throwing a dart away from me, I will see, the first thing I will see is the back of the dart, which is a cross. When a dart is coming towards me, which hopefully doesn't happen in real life, then I will see just a little tip of that arrow coming towards me, or that dart coming towards me. So that's just a way of being able to understand what is, how we want to show it. Right, so if I look at this graph now, here I've got the magnetic field between north and south. I've got magnets. And now you will understand my convention in terms of showing the direction of current flow. So the way that I've drawn it here, you will see the current is flowing away from my eyes into the page. All right? And I now would like to determine in which direction will this conductor experiencing, in which direction it will experience a force. It will either be A, B, C, or D. I only need to look at 90 degrees possibilities, because you will remember with Fleming's left-hand rule, we are looking at 90-degree possibilities. All right, so I'm going to decide now that I'm going to use my left-hand rule to determine the direction. Why the left-hand rule? Because electricity is supplied, and then this is the working of an electrical motor. So the motor effect is the principle I'm using. So if I use my left-hand rule, you there where you are sitting now, try and do it with me. All right, your index finger must point from north to south. In other words, from B to D. If you do that, now you must turn your hand that the middle finger is pointing into the page or into the board where you are seeing this picture now, towards the wall. Okay? Then you should experience now that your thumb is showing in the direction of C. which is downwards. So that means that this conductor will experience a force downward. So I hope that you are able to experience that. Let me give you 30 seconds just to use your left hand. Magnetic field, north to south, current direction, away from your face towards the board or towards the screen. Your thumb should be pointing downwards. Just check if you can see the very same. Right, I hope that all of you were sitting there now with your left hand, using it to see if you can apply Fleming's left-hand rule. If you are looking at this live, please feel free to type us some comments if you want more time that I must give when you want to emphasize things from the teacher's side, or you want to discuss something. Or if you are on playback now, please, teacher, pause this and make sure that every learner can actually apply this rule by himself. All right.